riverbed, doesn't it? Huh. Okay, look at that green. There we go. See, that's all along that surface?
Yeah.
Yep.
Yep.
Oh, that's right. Yeah, look at that. That's neat. Look, you can even see what certain color crystals right here. What color is that? See right there, white. And I don't know if you can see it, but it has that flat aspect to it that we saw with the feldspar.
So is it
Very often feldspar is in rectangular crystals, and so I think that's what that is. Oh, neat. Wow.
Holy cow.
Yeah. See, and can you tell that that green stuff is definitely thin layer on top, and then look at the pink. Pink. What mineral? Feldspar. Yeah, feldspar. You'll start seeing feldspar all over the place now, especially if it's pink, because it's easy to pick out if it's pink. But definite differences in the crystal size in that rock. There's a vein, 2 veins actually, through that rock, and it looks sort of salt and peppery. Okay, so it's probably that diorite that we had seen. Now, are the rocks that we're walking over, are they loose rocks or are they connected to the earth? Like the crust of the earth? Okay, well, it's a little hard to tell one from the other, except that if you can pick it up, obviously it's not connected, right? And if the kids think of the earth like an apple, what do they call the skin layer of the earth? The crust, that's right. And actually, geologists have another name. If you can actually see the crust, they call it bedrock, okay? So we're going to be looking for bedrock versus loose rock. Sometimes you can't tell, but sometimes you really can. So keep your eyes open and see if you can tell when we finally get to the bedrock. Oh yeah, there's a trail marker. We're in the right.
Oh, trail marker.
You have to know that this is one of my favorite minerals. Look at how shiny that is. What's it called again? Epidote. Epidote. Yeah. Oh, I'm not going to say anything.
Oh, look.
That's pretty.
There's a great piece of epidote.
Ooh, that's nice.
So. And there's more.
Bedrock. Bedrock. Yay. Okay. Now,
Fran, can you hold for just a second? Okay, so she's
Look at
asking if you're looking at the bedrock, which we
look at
just
this
came
glob
up to here.
What's that little glob in there?
Like a little teeny piece.
Well, look at it closely with your magnifier. Open up your little egg carton and compare it side by side with feldspar and quartz. That's what those little things are for.
So we're at the first outcropping of bedrock here.
Look at that. There we go.
Yeah,
I think green stuff. And yeah, and you can actually see the crack here. Remember we said it was in a crack? Well, we couldn't see the crack because we only had one piece. But there it is. There's the crack.
Can I ask you something totally different?
Sure.
What is that tree with the almost oak-like leaf that's kind of fuzzy?
And the ones with the little danglies?
Yeah,
Yeah. It is an oak.
it is.
Yeah. It's called a bear oak.
A bare oak.
Yeah.
I noticed there's a lot of them on the bike trail.
Yes. Yeah. Yeah. They like it where it's really dry. But you may have noticed now, what about looking at the tops of the trees here? Is it as painful on your neck? No way. Okay. So this is something that we will notice at the top, and after you've had a chance to look around, we'll see if we can figure out why the trees are like this here. Now you just found a little chip of Whipple Hill rock here. This is a little bit weathered, so it's kind of hard to tell, but if you look in your egg carton, there's a sample that has a fresh break, and it's labeled Whipple Hill rock. So it might be a good chance right now, before it gets too exciting when we get further to the top. Everybody's going to want to find the top and look around and stuff. So this is a good place to stop and see if the kids can figure out what kind of rock is there here at Whipple Hill. Now look in your egg carton. You can find some little pieces here, but they will be kind of weathered. Yeah, the crystals may look smaller if you see little pieces. This rock varies from one place to another, even over the top of the hill. But generally speaking, if you can see any crystals, they're considered to be medium to large. right? And the color is still pretty dark for most of them. And you found a little rust place there too, didn't you?
Is that what this is, Rust?
Yep, yep, rust from the dark minerals that are decomposing. Okay, did anybody find a place with a fresh break? Kind of hard to tell. It feels fresh-ish. Yeah, could be. The outside is actually coated with rust and with other iron kind of stuff that's getting washed out of the rock. So it's a little hard to tell that the inside might have shiny crystals like this. Okay, but at least it's some parts of Whipple Hill will look like this on the inside. So which is this most like in your labels? Yeah, the gabbro. And so some people, as they look at this, they say, well, I don't know, it looks more like the diorite. So scientists have a really good solution to that. They call this a gabbro diorite. And if you look on a geologic map of Massachusetts, that's what they call this stuff in this area, is gabbro diorite. Now, what does that mean, though? Where was this stuff formed?
Kind of close to the surface, but not as close as in between the granite and things like that, and the surface.
Okay. Well, actually, it has pretty big crystals. So geologists who are able to figure this out say 6 miles under for this.
Oh, really?
Around. I mean, plus or minus. But yeah, really deep. So that presents a problem.
How did it get here?
How did it get to the surface? Okay. So that's something that we're going to look for some clues about. Okay, already, have you gotten any clues as to how this could have gotten to the surface?
Earthquake.
Okay, could have had an earthquake where the stuff could move 6 miles. Okay, that's not unknown. But
Plates shift.
what is that?
Plates shift.
Plate shift. Actually, yeah. This have you been to Minuteman National Park over at Fisk Hill? Okay, right beyond that is Bloody Bluff. There's a big cliff over there. Okay, that's actually we are all part of what was once Africa. And there was a big crunch right over by Bloody Bluff. It's called the Bloody Bluff Fault, which means just a big crack in the rock. And there was a crunch over there, and then when Africa moved away to where it is now, part of it got stuck here. And we are right now we're sitting on part of the stuff that got stuck. So this is really part of Africa.
Cool.
So in Africa, there are rocks that are a lot.
There
like
are
this.
rocks that are similar. Yeah.
But western.
Yeah, the western side, right. All this stuff here, actually, dark rock is often associated with volcanoes. You notice that piece that I showed you is from Hawaii, but very often if you have a dark rock, it indicates some sort of volcanic activity. And if it's got the little teeny crystals or no crystals, it's lava that came to the surface. But if it's dark, it means it's the stuff that's solidified in that chamber below the volcano. And so that's what they think this stuff is that it's got large crystals and it's dark. And so we think that it may have been a feeder to an ancient volcano. We know there were volcanoes in this area a long time ago. So that's, and now how much of that you should go on with the kids, I don't know, because that's right at the edge of what they can understand. They can understand the colors, and maybe they'd identify like that quartz blob over there. They might be able to identify that. But you could sort of sense whether they're ready to go on, and just the idea of the crystal size being really large crystals means that it was formed deep. Now, again, the question of how it got up here. Could be an earthquake, but is there any other way for this rock to come to the surface?
Well, erosion.
Yeah, erosion. Actually, if it could either come to the surface physically, like earthquake could move it right up, or volcano. They always say volcanoes are going to shoot it up, but that'd be a little hard if the volcano solidified. It would have to be molten in order to come to the surface, and then it would have to have small crystals if it came to the surface when it was molten. So the idea of erosion, that instead of having it come up to the surface, what if the surface came down to it? Okay, and is that possible? You saw some clues that that's actually happening right now. What clues did you see?
The washout of the trail.
Yeah, well, yeah, the erosion of the trail, little bits getting moved away. and then the rocks actually decomposing in cracks and that rust, and everything. And even though that looks like really minuscule, still, if that happened over millions and millions and millions and millions of years, it could happen. Okay, so they think that this rock solidified something like 600 million years ago. And so since then, lots has happened, and it is entirely possible for 6 miles of rock to get worn away. So that's probably the most likely explanation for how come we see this here now.
It would have been uplifted too somewhat, though.
It could have been
too?
uplifted,
We
sure.
don't know.
Yeah, there could have been, another crunch, and the stuff could have gotten.
And what are
pushed
the
up, too.
oldest rocks? 3 billion in this country?
Yeah, right.
In
they
the
have
Appalachian, Appalachians?
some of the mountain cores, and in Canada, there's something called the Canadian Shield that has really old rocks. So these are relatively young compared to the oldest rocks in existence, but they're still not as young as some other rocks. In western Massachusetts, they have sandstones that dinosaurs walked on and so on, and those are much more recent.
What
So-
is this?
Oh, okay. Well, that would be a lichen. That's a kind of
like
lichen.
an old lichen or I don't know, it's just
Yeah,
Can't really-
it can actually,
it's like it's
I
gotten
wouldn't encourage you to do this too much, but you could actually scratch some of it off. Yeah, but that's a lichen.
You could also encourage your students to not walk on the grass, try to keep their feet on the rock so that they don't trample all the...
Yeah, the
Plants.
other thing is, of course, that this is tick season, so that's another good reason
Okay,
for
that'll-
keeping on the trail. And
Yep.
you might notice too that I want to be sure of how are people's times? Does anybody have to leave at 11?
I do.
Okay, well, I want to get you on the trail back before 11. We may not finish the walk with you at that time, but so we need to get to the top and
Okay.
then head back around. But at any rate, some of the plants here are very interesting because the only other place I've seen plants like this are mountaintops in New Hampshire.
Yeah.
See these shiny stuff? This is bearberry, and it has pretty red berries and all the while. I see it's blooming now, which is really nice. And I also see this a lot at the Cape, where it's very, very dry. So that's the thing about this mountaintop. It's very, very dry. Okay. Let's keep
One
going.
more question, Fran. We're going to have 4 groups here at once.
Yes.
In a class. How do you suggest spreading them out?
Well, you can do the rock geology pretty much anywhere you have some bedrock. So
Okay.
you could spread them out that way. Okay.
All right.
And then they'll be coming up at different rates. They won't all be coming up together.
Okay.
Okay. So I think they'll sort of spread themselves out. So, but that is something to keep in mind, though. You want to keep your groups sort of separate because otherwise they start chatting with each other.
Fran, unrelated off topic. Are the latest slippers behind Diamond, when do they bring?
Lexington Conservation Walks, they have a bird walk coming up from the journal. Look in the newspaper, they have. Yeah, as you're walking here, I want you to notice something about this.
Get all the glass here.
Better to get here in the back.
Glass.
Yep, lots of cracks.
It's got that kind of undulation of where it's
Yes,
eroded
it's
under the lake.
undulating, and if everybody comes up here, just keep walking. Okay, look back, and I want you to imagine now